Hello everybody and welcome to this new video. Today we are going to solve an adder by using an operational amplifier, and I'm going to show you two ways to do it, okay? So keep in the video, watch it up to the end, and you will learn and you will select which method is more suitable for you, okay? The first method we are going to use is the typical Kirchhoff current law, okay? So we're going to begin drawing current. We're going to select this node, for example, which is the same as this, okay? And we're going to call this I1. We are going to call this I2, for example. We are going to call this I3. This current going here, we are going to call it I4, and the current flowing through this resistor, we are going to call it I5. Okay, so remember that Kirchhoff current law states that the addition of the incoming currents equals the addition of the outgoing currents from the node. Okay, so in this case we have three incoming currents, I1, I2 and I3, okay, and we have this equals to the addition of the outgoing currents, which in this case are I4 and I5. Okay, so first of all, remember that the current going into the ports of the amplifier, in this case I4, by definition equals 0. Okay, and remember that by using Ohm's law, for example, we have a resistor, we have two nodes A and B, we have a current flowing this way, which causes a voltage drop with this polarity, let's call it I, and the resistor's value is R. So I know that VAB, which by definition is VA minus VB, equals I times R. So from here I have that I equals VA minus VB divided by R. From here we are going to write all of the currents in the equation, okay? For example, I1, which I drew this way from left to right, causes a voltage drop with this polarity. I2 causes a voltage drop with this polarity, and I3 causes a voltage drop with this polarity. The same way, the way I drew I5 causes a voltage polarity with a voltage drop with this polarity. So according to this, and by means of Ohm's law, like I said before, we can write this equation like this. I1 would be the voltage at this node, okay? So this is my reference node, whose voltage is 0 volt, 0 volt, 0 volt, and 0 volt. So to get the voltage of this node, if this is my reference node and I have a voltage raised this value, I know that the voltage at this node equals V1. The same here, it could be V2, and the same here, it could be V3. So turning back to the equation, I1 would be V1 minus the voltage at this node, okay? But remember that by means of virtual short, B minus equals B plus. So B plus is at a voltage, a potential of 0 volt, so this node is at the same voltage, 0 volt. So from here I have that I1 would be B1 minus 0 divided by the resistor's value, which is R1. The same way, I2 would be the voltage at this node, B2, minus the voltage at this node, which is 0 volt as well, divided by R2. The same for I3, which will be B3 minus 0 divided by R3. And this equals I5, which is the voltage at this node, which is 0, okay, minus the voltage at this node, which we call B0, divided by R. So we have B1 divided by R1 plus V2 divided by R2 plus V3 divided by R3 equals minus B0 divided by R. So by manipulating this last equation, I could get B0 equals minus R divided by R1 times B1 minus R divided by R2 times V2 minus R divided by R3 times B3. Okay? So here we can see that V0 is the negative addition of V1, V2, and V3 multiplied by these factors here. So this is an inverting adder. Okay? So now I'm going to show you the second way to do it. I think it's more suitable than the previous one, and you can select between both. Okay? So let's do it. So the second way I'm going to solve this problem, instead of using Kirchhoff's current law, I'm going to solve it by using superposition theorem. Okay? Superposition theorem states that in the case you have several sources in your circuit, you can get any variable of the circuit, in this case B0, by getting the individual contribution of each voltage source or current source separately. Okay? The only requirement you have to comply with to do this circuit this way is that the voltages or the currents in the circuit must be independent sources, okay? Like this case, V1, V2, and V3 are independent sources, and that the circuit is linear, which is the case of an operational amplifier with negative feedback. So we can write it this way. We can calculate V0 due to the contribution of, we are going to call it V0 due to V1, nullifying V2 and nullifying V3. And we add the contribution to V0 due to V2 with V1 nullified it means V1 equals 0, and V3 nullified. And finally, we add the contribution of V3. So we get V0 due to V3, okay, which source 1 nullified and source 2 nullified. So now we're going to draw these three circuits separately, and we are going to calculate the contribution of each one to the output voltage. Okay, so in this case I'm going to use this first circuit to calculate V0 due to V1 with V2 and V3 nullified. Okay, to nullify a voltage source, I mean to make a voltage source V0 means to short circuit it. So to nullify V2, I substitute the original source with a short circuit. Okay, this is V2 equals 0. If we had a voltage, a current source there, we simply take it out, okay? Because to nullify a current source means to make it 0. It means that it is an open circuit. For V3, we do the same. We short circuit where we had V3, we short circuit, which means V3 equals 0. Okay? So in this case, if you try to apply Kirchhoff current law to solve this problem, you are going to find something very interesting. Okay, look, this node is my reference node, which is at 0 volt. Due to virtual short, this node is at 0 volt, okay, because my positive input port is connected to ground, so its voltage is 0 volts. So by virtual short circuit, V minus equals 0. So going back to Ohm's law, okay, which we drew before, if you see carefully, the current flowing through a resistor equals this. In this case, this node is at 0 volt. This node is at 0 volt. So the current flowing through R2 equals 0. So it is as if didn't exist. So we can take R2 out of the circuit. The same happens with R3. This terminal of the resistor is at a voltage of 0 volt, the same as this. So the resulting current through this resistor R3 equals 0. So it is as if it didn't exist. So we can take this resistor out of the circuit. So if we see carefully, look that the remaining circuit, this circuit here, is an inverting topology, from which we know that the output voltage will be minus R divided by R1 times V1. I'm going to leave you the link to this video, the inverting topology, if you want to realize how we calculated it. So we know that the output voltage of an inverting topology is like this. So let's proceed with the second one. In this case, I'm going to calculate V0 due to V2 with V1 and V3 nullified. Okay? So, again, to nullify a voltage source means to short circuit it. So, where V1 was connected, I'm going to substitute it with a cable. Okay? This means V1 equals 0. And to nullify V3 is the same. I connect this terminal to this terminal by means of a short circuit. So V3 equals 0. So the same as before. This node is at 0 volt. This node, due to virtual short circuit, is a 0 node. No current flowing through this resistor R1, so I can take it out. And the same happens with R3. This terminal is at 0 voltage. This terminal is at the same voltage. The resulting current through R3 equals 0, so it is as if it didn't exist, so I can take it out. Okay, so the remaining circuit is an inverting topology as before. So V0 equals minus R divided by R2 times V2. And the same for the third voltage source, V3. I'm going to calculate V0 due to V3 with V1 and V2 nullified. So we nullified V1. So we replace V1 by a short circuit. We nullify V2. We substitute V2 by a short circuit. This node, due to virtual short, is at a voltage of 0 volt, the same as this. The resulting current through R1 is 0, so if it is as if R1 didn't exist, I can take it out of the circuit, and the same happens with R2. So the remaining topology, which is this one, is an inverting topology from which we know that V0 equals minus R divided by R3 times V3. So remember that we said that V0 will be V0 due to V1 plus V0 due to V2 plus V0 due to V3. So V0 will be minus R divided by R1 times V1 plus minus R divided by R2 V2 minus R divided by R3 V3, which is the same result we got before by using Kirchhoff current law. I think this one is more suitable, is more comfortable. Do it as you feel, the best way you feel you can do it, the simpler it is for you, okay? So, 2 ways to do it. If you liked this video, thumbs up, and please subscribe.